And here we go. The long-awaited atmospheric change is happening. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 16th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you'd like to leave a comment or question, please do so down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below. And with that, I'd like to thank the folks that donated last week. B. Nadine, BC Hall, and the big contributor, Skipper N. Thank you all so much. With that, let's get to work. First off, let's take a look at significant wave heights around the planet. Starting in the North Pacific, a bit of a gale, really diffuse, but over a broad area, producing anywhere from 20 to 25-foot seas, targeting mainly Hawaii, but at some point we believe energy will be reaching towards the California coast. Remnants of a gale are also here off the Pacific Northwest, but not really doing anything of interest. In the southern South Pacific, we got a little area of barely 24-foot seas, and really nothing expected from that. Though there was a gale here that pushed well to the north, maybe going to make some background swell for Southern California at best. North Atlantic, pretty quiet for the moment. South Atlantic, a gale with almost 28-foot seas, somewhat targeting South Africa. And over in the Indian Ocean, another gale with 24, 25-foot seas, producing some energy radiating up towards Bali and South Australia. But all in all, kind of a quiet pattern for the moment. So let's go take a look at current conditions. We're going to do that by looking at the buoys. We'll start up off the Pacific Northwest. Grays Harbor Buoy in Washington, buoy number 036, right there off the intersection between the border between Oregon and Washington. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period energy. We see a tenth of a foot there. That would be very energetic swell, but at a tenth of a foot, it's not even noticeable. It's probably just background noise, if anything. And then the graph goes the whole way down to 5 second period, just pure unsurfable wind chop. We see a bit of energy there, probably the biggest peak somewhere in the about 13 second range with a little energy on either side of the hump there. Kind of a mix of a whole bunch of stuff. Let's see how the algorithm does. Primary swell, 4.2 feet at 10.3 seconds from 280 degrees, making surf at 4.3 feet. And then some secondary swell, 2.4 feet at 15.5 seconds from 271 degrees, 3.7 feet. All that's probably the same bundle of energy, just looking at the graph. Where was that? 10-second energy, 15-second. It's just probably more of a jumbled mess than anything. Oh, the chop height here, that sort of tells it. 2.3 feet. Anything at about 2.5 feet and above is pretty lumpy and pretty bad. When you get in 3 feet, it gets really ugly. Then we head down to Northern California, the San Francisco Buoy, number 46026 there, inside the Farallon swell shadow. Mainly a buoy for shipping channels coming out of the Golden Gate there, but got to make do with what we have because there are not a whole lot of buoys in operation at the moment. Again, looking at the profile, all this just looks purely like wind swell in about the 10-second period range. The algorithm pretty much confirms that. 5 feet at 10.6 seconds from 304 degrees, making surf at 5.3 feet, and literally no secondary swell, so you got that. Down to Southern California, off of San Diego, the Point Loma South Buoy, number 191. Profile, sort of the same, a little bit of 13-second period energy in the mix there, and a bunch of wind swell, sort of not particularly big, but filtering through the Channel Islands. Primary swell, 2.2 feet, 13.3 seconds from 205 degrees, so that's actually southern hemi background energy there, making surf at waist high or so. And then secondary swell, 2.3 feet at 10.1 seconds from 252 degrees. That angle gets twisted as the north swell comes through the Channel Islands. brings it more straight on, making surf at thigh high or so. And then finally over to the north shore of Oahu, the Waimea Bay buoy number 106. Have a little bit of energy here in the 13 second period range. I assume that is swell that was generated previously off the Kuril Islands, the Northwest Pacific. Primary swell 3.9 feet, 13.5 seconds from 314 degrees, making surf at 5 feet, 5.3 feet. Then some wind swell in the mix, 2.4 feet at 10.3 seconds. Certainly not from 172 degrees on the North Shore, but that's probably wraparound wind swell from the northeast, making surf at 2.5 feet. All right, so let's take a quick review of what's gone on for the past week in the North Pacific. We're looking at significant wave heights here. The highest, 1/3 of all waves in the North Pacific Ocean, right here, 29.2 feet. That is the highest seas over this entire image or domain, and here are the coordinates, and here's the winds. That's typhoon energy pushing into north of the Philippines. That was during last week's video. Here we are into Monday, the 10th of November. A little bit of a gale here developed off the Kuril Islands, producing 24-foot seas. Right about there. That is probably the swell that's hitting the Hawaiian Islands as we speak. There was also this gale, or trying to be a gale, developing here off the coast. We'll put that into motion. You see it started winding up on Thursday. Friday, there we go, at 28-foot seas or 29-foot seas targeting San Francisco. That produced swell pushing down the coast, but it was pretty raw and lumpy and pretty ugly and not particularly appealing. And we're into Friday, Saturday. Another low pressure tried to wind up here in the Gulf, but North Gulf, but too far east to make any swell relative to California. And then another gale here developed on the dateline on Saturday with 27-foot seas. There we go, to 30 feet. Most of this aimed to the north, but maybe some sideband energy will work its way over here, but I don't think anything relative to Hawaii. There's some other additional energy behind that into this morning at 24 feet. Probably not doing a whole lot. And there we are at current time, a secondary fetch starting to develop here. But notice this whole area from the northwestern Gulf to almost, we'll say the Kuril Islands, agitated with seas 18 feet or greater. That should be good for wind swell, sideband wind swell radiating down on the Hawaiian Islands and some sort of energy into California, but nothing too particularly impressive, at least yet. In the southern hemi, we're going back a week. There was this little gale that developed, I think it was about midweek. There it is, right there. Thursday, lifting north with 25-foot seas up to 27 feet. This is Thursday evening. One more reading at about 20, we'll say 27 feet. And then the system pretty much started fading out from there. Tiny background swell. We're talking like 1 foot at 15 seconds or something is expected into Southern California about 6 days from whenever that was. Friday, let's say Thursday night, so that'd be like Wednesday, something like that. Nothing particularly big, but perhaps rideable surf to result. And then let's just roll this on out to current time. There's really nothing else going on. Over to the North Atlantic a week ago, a little bit of disturbed weather, 22-foot seas or so in the area, generating wind swell pushing into Europe. This was about on Tuesday or maybe Wednesday sort of thing. Notice all the energy was kind of right here. A big low-pressure system was circulating here, producing offshore winds for the northeast U.S. coast. A little bit of circulation. See, look, this wind or the fetch direction was northeast relative to Ireland, so not sure anything has been generated by that. We'll just take this. There we are, current time. Not a whole lot going on, so interesting. To the South Atlantic a week ago, a gale with, 29.3-foot seas developed, but fell southeast. Didn't do anything relative or anything particularly meaningful other than maybe wind swell. South Africa here, we're already into Thursday, Friday the 14th, Saturday, And now Sunday, still nothing, a little gale, 28-foot seas. I mean, given the time of year, it is getting to be summer, or I guess it would be really spring for the southern hemi. So not surprising there isn't a lot of surf going on. And then to the Indian Ocean. Again, starting out a week ago, the 9th of November, just looking for any hope of meaningful swell or storm develop. We're in Saturday, Sunday, 28-foot seas, but aimed southeast. So kind of quiet for the past week across most of the planet's oceans. So let's take a look forward. We're going to start by looking at the Jetstream. The Jetstream winds up about 30,000 feet. These winds help support the formation of gales. When a gale forms, help direct their track. We're looking for a trough, a pushing the jet to the south. You see a little one right there, and a much steeper trough there off of California. Decent amount of winds. In general, the jet pushing east on about the 40 north latitude line, which would be about normal for this time of year. Winds up to 140 knots, 150 knots in a couple of pockets. The trough, the dip in the jet to the south, what that helps do is create a counterclockwise eddy in the upper levels of the atmosphere. And that's the hallmark of low pressure. And of course, low pressure, if it's strong enough, makes winds, and those winds manifest themselves down on the ocean surface. Those winds impart energy to the ocean in the form of like wind waves. Those wind waves generate seas. Those seas, if they get big enough and the wind is strong enough, eventually start radiating away from the fetch area. The lesser period elements decay away, exposing swell. Swell, when it hits your beach, turns into surf. So we have a little bit of potential here just west of the, almost on the date line. Then we have a steep, almost pinch trough, one there, and a second trough that pushed over California, or Northern California this morning. Let's put this into motion. So we get into Monday, the next trough pushes into the San Francisco Bay Area. The generalized weak trough pushes over the date line. You see this backdoor trough, if you will, pushing down into Southern California as we get into Tuesday. The trough over the date line moves to the northwestern Gulf, but kind of pinched off, not super great. Notice winds, though, build to 170, 180 knots as we get into Wednesday. No real troughs indicated. Here's another one of these steep troughs pushing into California theoretically on Thursday, supporting low pressure development, big backdoor low, maybe some precip and something like that. So we get into Friday, the 21st. Now the jet still running more or less west to east, but not as strong as it was, and if anything, getting weak over the date line. Notice the cutoff trough here off of Southern California, even into Friday and Saturday. Finally pushing onshore Sunday, a week out, and we'll just take this out to the logical extreme. The jet at that time, not very strong. Now notice, it's not like split or anything. It's just generally kind of weak and not super supportive of gale development. So then we go down to the ocean surface. Surface level pressure, surface level winds. We know there's a trough here, and sure enough, here's low pressure. It's actually up in the Bering Sea, but fetch from it, generating 30, 35 knot winds are gale force, so just barely gale force. Hawaii down here, California over here. So maybe some like 12-second wind swell targeting Hawaii. Then something trying to organize here off the California coast. So we get into Monday, the weakest of weak low pressure areas pushes over San Francisco. Fetch, not building, but holding at 30 to 35 knots, again targeting Hawaii. Falling southeast, you notice some sort of weak low pressure still over the California coast, but nothing particularly organized. Now here is a gale with 40 knot winds, 45 knot winds. This is on Tuesday, the 18th of November, pushing to the date line. Still not like super organized. The front is way out in front of it. The core of the low's back here. Just not super organized, but then we get into Wednesday. Sure, that'll generate some seas, but a new low supposedly winding up. This low comes and goes with almost each run of the models. 40-knot winds aimed at San Francisco, falling south while fading, while the other low holds over the date line. And then theoretically on Thursday, it all kind of coalesces with 55-knot winds, but way up here to the north. Not very ideal for swell production for anywhere but maybe Alaska or Vancouver Island. Another little low pressure system theoretically forecast Friday off the California coast, but not producing swell, maybe some weather with luck. Push this into motion, another low winds up, but it's all up in the Bering Sea. We're out 180 hours. And again, it's this kind of weak pattern, sort of like what the Jetstream suggests. Not super organized, but not unorganized. Not great for swell production, not great for weather production, but not completely high and dry either. So let's go take a look and see what effect those winds are going to have on the ocean surface. So here we are, current time 18Z Sunday, the 18Z run of the model. That's really 10 a.m. local time, California. Yeah, 20-foot seas, a little bit higher, but most of it all aimed up at the Aleutian Islands and Alaska. Only 22-foot seas here aimed at Hawaii and pretty good distance away. So we get into Monday, that fetch continues in the producing 20 to 22-foot seas targeting Hawaii. That fades out. Next low winds up as we get into Wednesday. Little tiny one here with 30-foot seas targeting California well on Wednesday the 19th, and then a broader complex low. Again, the main core here, the front out here, producing 25 to 28-foot seas aimed off to the east, building to 33 feet Wednesday night. This other low approaching the coast on Thursday. Broad area of 20-foot plus seas from, like west of the date line the whole way into the central Gulf almost, with seas building to 42 feet, 46 feet, but again, all aimed off to the north. Great for Canada, Vancouver Island, maybe even down into Oregon, but get further south into California, you're 45 plus degrees off the Great Circle Path axis coming into California. Probably not a whole lot of swell to result. We're into Friday, Saturday. We're just looking for something out in this area, and it just isn't happening. This is not unexpected given what we kind of surmised based on low pressure biases, the MJO, all that stuff we're going to get into a bit. This is exactly kind of the pattern we'd expect. Energy off here, energy here, but kind of a high pressure ridge here driving everything to the north. For the South Pacific, here we are starting current time. We'll run this through. Now, given that it's mid-November, the expectation is there's not going to be a whole lot going on here. We're looking for anything with 28-foot seas. Nope, not a single thing. So pretty quiet from the southern hemi. For the North Atlantic, we'll see. Now, theoretically, well, again, low pressure here, driving offshore winds. You'd think something would be happening, but again, seems to be pretty on the quiet side. There we go. Something, finally, a week out. Don't believe the model's a week out, but what do we have here? We have, pull this up here, there we go. 33-foot seas over a small area. And quickly fading as quick as they form, down to 20 feet a week out Sunday night, targeting Ireland and France and probably a little bit here into Portugal. To the South Atlantic, little gale has 28-foot seas, building to 30 feet but falling off to the southeast. Another one producing 37-foot seas on Tuesday, the 18th of November. This offering better hope. You can see energy, South Africa right in here. So there we go, and you can see a swell front actually theoretically pushing up into there as we get into Thursday, the 20th of November. The gale lifting north while fading. We're into Friday, Saturday. After that, if this forms, that'd be a pretty good late season storm and or swell for South Africa. So something to look forward to if you live there. Then to the Indian Ocean, current time. Looking, we have an area of 27-foot seas as we get into Monday morning, targeting southern Australia. Lifting northeast, certainly a bullseye target right in that area there. Onward, let's see anything else possible. Friday, Saturday, Sunday. No, pretty quiet, as would be expected for this time of year. Let's take a look at local wind conditions for California, Hawaii. So California's here. That'd be Southern Cal. There's the Baja border right there. So Southern California, Point Conception, Monterey Bay under the tag, the Golden Gate Bridge right there. There's the Oregon-California border. You see Oregon up in here. Hawaii right here. Current setup, trades, pretty much normal, 10, 15 knots for the Hawaiian Islands. Some sort of a south wind flow over the Bay Area on Sunday afternoon, but you see the new low. It's not even a closed low, but it's more of a trough setting up as we get into, well, right about now as I'm recording, south winds building 15 knots. And we see a core closed isobar low develop overnight, push on shore right over the San Francisco Bay Area, south winds. Monday, trades 15 knots for the Hawaiian Islands. Tuesday, the low moves inland, high pressure off the coast. The gradient between the low inland here tightens up the isobars, produces north winds down the coast. Trades in the 10 to 15 knot range for the Hawaiian Islands. Wednesday, light northwest wind regime for California. Trades, though, building, notices high pressure here. 15, 20 knots from the east for the Hawaiian Islands. Low pressure in the Gulf. You see that looking pretty good. Targeting California well. A light wind regime Wednesday afternoon. But by the time you get into Thursday, you can see it says light winds. It's pretty just a torn up mess off the coast. My guess is, yeah, it might be clean, but the sea state will be pretty jumbled. Trades 20 knots for the Hawaiian Islands on Thursday. Low pressure continues circulating off of Southern California as we get into Friday, but probably a northeast wind regime here as winds circulate counterclockwise around the low. If there is any swell, might be clean. Trades 15 knots for the Hawaiian Islands. Saturday, same deal. Low continues off the coast, light wind regime. Trades southeast 15 knots for the Hawaiian Islands. Sunday, the low finally pushes into Baja. Still, not strong winds for California. Cutoff low, it looks like forecast developing north of the Hawaiian Islands. Let's see if that actually, there you go, even more so. Some sort of a southerly wind flow for the Hawaiian Islands. Local low on Sunday night developing off Vancouver Island. Precipitation forecast for California. You can't even see it. It's buried under all the precipitation, which is a good thing. But Baja here, let's see, where are we? There's the border. Southern California under there. I mean, this is all be, as of right now, probably light showers. Same thing the whole way up. But the new low trying to wind up. Rain starting to build into Northern California by 10 o'clock tonight. The front pushing down to about the Golden Gate. And then down the coast, snow in the upper elevations of the Sierra. There you go, legit snow as we get in Monday. Rain building south to LA County by about 10 a.m. And let's see if it makes it any further than that. Snow continues, though rain lightening up for Northern California. Finally, there we go. The rain front or cold front, if you will, pushes down to Tijuana, if not further south from there. Snow continues for the Sierra. And then by Tuesday, this low continues circulating off the coast, but at best, maybe showers for Southern California. No snow for the Sierra. And then we're into Wednesday. Things clear out. Now, here's the next bit of weather forecast. Some model runs have had it off the coast. Some have had it nearer to the coast. The nearer or closer over the coast it gets, the better the odds for rain and certainly for snow in the Sierra. As of now, Thursday, it looks like rain and snow, light snow over the Sierra. Does the rain make it to Southern California? Lightly, but it makes it with light snow in the Sierra Thursday night. And then that all starts falling south, probably again a more of a rain event for Southern California. No complaints, take what you can get, because the rumor is that after this, things dry off. dry out and get much warmer after that. You see more rain even into Saturday for Southern California, pretty much holding. There we go. In the afternoon, it finally clears out. We're into Sunday, and then it's pretty much all over except for that little low up there. And again, never believe a model a week out. Here's the snow forecast dashboard for Olympic Valley, formerly Squaw Valley, also known as Palisades, Tahoe. Total accumulation looking at about 14, 15 inches and all that pretty much as of just today. What's today? The 16th and the 17th. Now, this is the 12Z run of the model. The 18Z runs showed some sort of additional precipitation out here on the 19th and 20th, but the model just hasn't got there. I got as many computers going as I can possibly stand to try to keep this up to date as quick as possible, and we're still not there. Snow levels. The good news is here. So this is the base of Palisades, Tahoe. This is the summit up at the top of the Palisades. The red would be liquid precipitation. This is by elevation. The gray is sleet. So the intersection of the white and the gray is the 32-degree freeze line. So as of right about now, give it about 3 hours. We're supposed to have freezing temperatures down to the base, if not below. It's been snowing there all day. Freeze level, as best I could tell, was the parking lot's about 6,200, so about 7,000 feet. Somewhere about 2/3 of the way up Red Dog, it was white. Down below that, it wasn't white, it was green. So, but further up, high up, up at Gold Coast and Siberia and that, there was a good amount of snow on the ground. I mean, everything was basically covered. Not saying that it's skiable yet, but at least there was a good amount of snow on the ground and more expected overnight, and possibly more into Thursday with freeze levels still reasonable than you see once you get into the 20th. What's that? Like 4 days from now. Then all of a sudden we have freeze levels back up at like 11 to 12,000 feet. So a big warm up coming as we get later in the week and into the weekend. Since these systems are falling south, Mammoth, which is further south, gets a little bit less snow, maybe 10 inches sort of thing, but they have elevation, and the elevation helps actually wring out more moisture out of the whatever rain is falling. So maybe this might be a little bit on the low side. There was a good amount of snow falling though as I was looking there through the day today. So let's say 10 inches, maybe a foot expected. And again, here's the elevation difference: 8,000 versus 6,000 feet. The summit up here at 11,000 feet. The freeze level minimum 1,000 feet below the base, and sometimes much more depending on what cycle the storm is going through. But again, this big warm-up where it's almost above freezing, not as bad as at Palisades, Tahoe, but still definitely getting warm later in the week and into the weekend. Let's go take a look at surf forecasts for a couple locations. We'll start up at the Columbia River there, right intersection of Oregon and Washington. Surf heights building some on Monday up to the 10-foot range, falling down in the 6-foot range on Wednesday. Then as we get into Thursday, early Friday, 12 feet and 17 feet as we get into Saturday and Sunday. I think that's all dependent, though, on that little local low that's forecast winding up off the coast. Winds out of the south at 16 knots, something like that, by the weekend. Swell heights, 8 feet at 12 seconds, 4.5 feet at 13 seconds, 9 feet at 13 seconds, 10 feet at 16 seconds. That's significant swell. If it happens, all dependent again on what actually happens with a low forecast almost a week out from now. Ocean Beach, San Francisco, surf heights not doing a whole lot. Here we are Monday. West winds at 25 plus knots. What a mess that'll be. And you see when the wave heights drop out like that, it's pretty much just unrideable wind chop. Anyway, winds start lightening up on Tuesday. Surf heights down into about the 7-foot range, dropping from there. Next front shows up. Then surf heights in the 12-foot range. Notice the northeast winds here. This would be on Friday. And then into Saturday, some flavor of north to northeast winds with surf heights to 10 to 11 feet. So maybe an improving pattern, but I think a lot of this, again, is all dependent on that local low that's forecast forming. Swell heights, well, just garbage Monday. Tuesday, 7 feet at 9 seconds, just wind swell, 3 feet at 9 seconds. Then we're into Friday, 9 feet at 13 seconds, 6.5 to 7 feet at 12 seconds, 13 seconds, and then there we go, 7.7 at 16 as we get into Saturday and Sunday. So real swell, but very dependent on one little local low pressure system. San Diego, not a whole lot happening until we get into Tuesday, maybe some 4-foot surf, fading down to 2 feet and pretty much unrideable into Friday. And then we get into late Friday and the weekend, 4-foot surf, 3-foot surf. Wind's not really an issue at any point in time. 3 feet at 11 seconds, 4 feet at 11 seconds on Tuesday, dropping out from there. 3 feet at 13 seconds Friday into Saturday, and 2.2 feet at 16 seconds, and probably pretty shadowed, probably a lot steeper north angle than what the model suggests. Over to the north shore of Oahu, 3-foot surf pretty much Monday, Tuesday. Wednesday, things pick up. Notice the trades are really blowing 25 knots sort of thing. That is knots. Yes, it is. And let's see, 10-foot surf on Thursday, fading to the 5-foot range, and then 8 feet with a lesser wind regime as we get into the weekend. Let's go look at swell heights here. 3 feet at 8 seconds, 2.5 feet at 11. Anything interesting? Here we go, 7.6 feet at 13 seconds, that quickly fading out, and then in the weekend, 5 feet at 14 seconds. So maybe some hope there. And then for fun, over to Jefferies Bay, South Africa, surf heights supposedly 12 feet today, but then fading down. Not a whole lot happening until we get into Friday when that low pushes near the coast. 20-foot surf there, and then slowly working its way down. Winds, let's see, well, that'd be onshore from the south, so you got to pick through this, know your spots. Swell heights, 10 feet at 12 seconds, that was today. Fading out, going up to 12.5 feet at 15 seconds on Friday. That looks like a good bit of swell right in that Friday-Saturday time period. Then finally, on to Mr. or Mrs. Reliable Bali, or Miss Reliable. Either way, surf height 7 feet, 6 feet, slowly working their way down. Not as reliable as it has been over the months. I mean, we're moving into the summer season, so it's not unexpected. So 4 feet there as we get into next weekend. Swell height 4 feet at 15 seconds, 4 feet at 13 seconds. Dribbling down, that swell fades out. Next swell builds up to 3.3 feet at 13 seconds, and that's about all there is. All right, let's go to the long-term outlook. We're going to examine the two major weather oscillations that affect our weather long-term. That is the MJO, the Madden-Julian Oscillation, and ENSO, El Nino Southern Oscillation. We're going to start with the MJO, the Madden-Julian Oscillation. This weather oscillation has a major influence on the jet stream and storm production. There are two phases to the MJO, the active phase and the inactive phase. Active phase on one side of the planet, inactive phase on the other. They rotate west to east around the planet. The active phase, on the equator. The active phase is like a low-pressure system. It takes warm, moist air at the ocean's surface, draws it aloft. That energy gets caught by the jet stream, making the jet stream stronger, more supportive of gale development. Inactive phase does the exact opposite. It is a high-pressure system, creates falling air that cuts off the flow of energy to the jet stream. The jet stream gets weaker and splits, not very good at supporting gale development. If anything, it does the opposite. It supports high pressure. The other thing is trade winds. So trade winds are heavily influenced by the MJO. The active phase of the MJO being a low pressure system and trades being generated by high pressure. Well, when the active phase of the MJO moves from west to east across the Pacific on the equator, that low pressure system, as it's chunking across there, basically dampens the trades. It cuts the legs out of the trades, and so trade winds get weaker, if not even reversing direction. That is good in terms of support for storm production, and wherever it is, being a low-pressure system, it helps promote storm production due north and south of where the active phase of the MJO is as it's moving across the Pacific Ocean. The inactive phase of the MJO being a high-pressure system and trades being generated by high pressure, well, the two marry up and then trades end up being stronger than normal, and that's not good at all. All right, so we can look at this data from the TAO buoy arrays, series of buoys strung across the Pacific. East Pacific here, West Pacific here. Here is the equator, the international date line right there. These buoys have wind sensors on them. You can look at the arrows. They just tell you how strong the trades are. Longer arrow, the stronger the wind. So you see pretty strong trades here in the east. Oh, and that's the date line right there. Hawaii would be somewhere right around in here. North of this only goes north 10 degrees, south 10 degrees. Trades pretty strong in the Central Pacific. Pretty strong in the West Pacific, though much weaker than they were last week over here. And I sure wish this sector of the array was up so we could see what was going on, because that's really what matters. Anyway, it's not the actual wind speeds. It's the anomalies, the difference from normal for this time of year. You're looking here at the arrows. There's, well, maybe a little bit stronger than normal. But over the Central Pacific, pretty much normal. In the West Pacific, just slightly stronger than normal. This is part of what we're watching, as we know, and what the title of the video was talking about the big change that we've been waiting to happen. We believe it is happening right now, and we've got a bunch of data to support that. We'll show you that in a minute. But most of it is happening right off the edge of here. It's like from 150, so right over in here. Doesn't do so much for us, but it does, directly, but it does good for the jet stream. All right, let's go look at the forecast, see what it is for the next 14 days. Here is the 850 zonal wind anomaly forecast for the entire planet. Blues, easterly anomalies, roughly the inactive phase. Oranges and reds, westerly anomalies, the active phase. But you notice they're not moving anywhere. All right, and the date line. So this is the whole planet. The date line's right there. Far West Pacific starts right there at 125 east. This is past performance here. So you see westerly anomalies started moving into the Far West Pacific about October 20th and have been hanging here pretty much nonstop till today, and are forecast holding in some fashion into about the 26th of November, then maybe retrograding a little bit, at least according to the GFS model. Now, the interesting thing about this is when you have westerly anomalies at the entrance to the West Pacific, the jet stream is moving west-east. It moves over this area, gets additional energy feeding into it, and that gives the jet stream energy to consolidate and be stronger, pushing over the date line, which is at 180. California's at 120. So it'll give the jet stream good energy. But notice, just like when we've been looking at the charts, the jet stream is strong coming off Japan, and then it starts like lifting northeast into the Gulf of Alaska. I think a lot of that is because this is pumping energy into the jet stream. But as the jet stream goes further and further across the Pacific, it loses energy and starts drifting off to the north as high pressure builds off the California coast. That said, we have been lucky in that we're getting these backdoor troughs, these splits or these tight dips in the jet stream that fall south that have been providing rain for California. But that is not an expectation. That is more of a gift, given this whole scenario. Anyway, the forecast, you see pretty much the same thing holding until we get to about Thanksgiving, maybe a bit of a break. Now, it doesn't happen exactly like that. If the westerly anomalies that are forecast here, they give up for a little while, the jet stream has momentum, and it'll keep going for a week or two, and then it'll start slackening off as it senses the change in the tropics, if the change is permanent. But you see, if you just look at a couple little areas down here, suspect this is probably not a permanent change. And if anything, these models change every 6 hours. So we'll just have to keep our eye on it. Here's the MJO forecast for 2 weeks, but not the wind forecast. This is precipitation, okay? Active phase of the MJO, because it's low pressure, takes warm, moist air at the ocean surface, lifts it aloft. Eventually, as that moist air gets higher up in the atmosphere, it gets cold and condenses into clouds. You'll get more clouds than normal. So let's take a look here. South America, Central America, Hawaii. EQ is the equator. Dateline right there. There's New Guinea. And again, the MJO travels west to east on the equator around the planet. So you see the active phase here. The blues is less clouds than normal, more condensation. So one would assume this is the active phase. Inactive phase over in the Indian Ocean. There's India right there. This is a statistic model going out 5 days, 10 days, 15 days. Basically unchanged MJO setup. That's nice. Let's go take a look at the GEFS model. It's saying the same thing. Maybe the MJO getting a little bit weaker 2 weeks from now, but not too bad. So all in all, this indicates a pump feeding energy into the jet stream. Not super strong, but the pump continuing just the same, feeding the jet moving across the North Pacific. Here is phase diagrams for the same two models. This is the detail. This shows you exactly where the active phase of the MJO is. How do you read the chart? Well, the MJO moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Heavy dot is where the active phase is, so it's right where we want it to be, in the West Pacific. The further the dot is away from the circle, the stronger it is. So strong is up in here, moderate is here. I'll call this modest, but certainly not weak. Active MJO, according to the statistic model, 1, 2, 3 different branches or runs saying, well, the active phase may be moving to the East Pacific 2 weeks from now, or two others say over Africa and very weak. The dynamic model has the active phase just noodling around doing circles in the West Pacific at weak to modest strength for the next 2 weeks. That is really nice. And actually, the GEFS model, the dynamic model, is by far the more accurate of these two models. Then we go to the CFS model. This is a dynamic model that's optimized to go out longer in time. This one goes out a month, from November 15th to December 15th. Again, the whole planet, east and westerly anomalies. The date line right here at 180 west. The far west Pacific starts at 125 east. So the area we're interested in is right about in here, the Kelvin wave generation area. And this also has the MJO on it, the solid black contour. So you can see back early part of October, the dotted contour is the inactive phase of the MJO with easterly anomalies. And then here is the active phase, and you can assume you can kind of connect the dots right here. And the active phase, at least according to this, somewhere over the date line, probably right about now. You see westerly anomalies reaching to the date line, but a day or two from now, you see their forecast to sort of fall back, but holding the entire time right about 150 east. So getting into the West Pacific, but not deeply into the West Pacific. And looking further out, we don't see really any MJO activity at all. So I have learned a little bit about this model. So this model, when it calls an MJO and draws the highlights, it's calibrated to be, it takes a much stronger sort of event than what the next model it's the same model, but the next chart looks at. So this is less sensitive than the next model, but just the same, it still depicts pretty much westerly and easterly anomalies in the same deal. So we're kind of locked in this pattern. Westerly anomalies in the far West Pacific, easterly anomalies over the date line. Let's go look out a little bit further. This is the CFS model going out 3 months. Okay, past performance here, the forecast here, same deal as what we've been seeing for weeks and months now. Easterly anomaly. Oh, the date line runs right up the middle. Okay, far west Pacific starts 125 east. So here you can see, as of right now, I think the change has happened, and I pretty much said it in the title of the video. Let's see, what is it? And here we go. Long-awaited atmospheric change is happening now. I think it's pretty apparent that it is. You see westerly anomalies the whole way over to the date line, and forecasts staying that way from now on. And if anything, building to the east, building to us point almost south of California here. Now, that's not till almost a month from now, but still, this is what the model has been hinting at. It took it a while to get there, but it seems like that is what is happening now. The change is happening. Let's overlay the MJO, and you can really see what's going on here. Here's our strong active phase of the MJO, which really isn't that strong. I'll call it a modest active phase of the MJO. You see the darker shades of orange here. If you were in El Nino, they would be red, and it would all be right here in the middle. So we're not talking anything near some sort of a major El Nino, but we're just talking about a generalized transition from what I would say is a pattern in the Pacific dominated by easterly anomalies and higher pressure, which one can loosely associate with La Nina, to something that is probably just more akin to being neutral or normal, but not El Nino per se. Okay, you see as we move into the future here, another, like, they're pieces of active phase. Again, this model way more sensitive in how it draws all this stuff out. But I would say roughly all this is one interconnected active phase of the MJO that just ends up stalling somewhere south of Hawaii with weak inactive phase somewhere over the entrance to the Pacific, but none of this particularly strong or meaningful. The high pressure, low pressure bias. This is what really matters. Dotted contour, the high pressure bias. The solid contour, the low pressure bias. The El Nino signal and the La Nina signal. So the high pressure bias last winter was fully just like over the date line. You see it is shifted to the east. The dividing line between the two is like at 160 or maybe even 165 east. That's supposed to hold until somewhere here. It depends which hour you look at this model, but it says anywhere from late December to maybe into mid-January. Then all of a sudden, the high pressure bias completely collapses and the low pressure bias swings off to the east over towards the date line. If that were to happen today, if it was literally happening now, I'd be pretty excited. But seeing how it's not going to happen until February, by the time that really starts manifesting itself in the atmosphere, winter will be over. Still, I'll take this any day of the week over where we have been, which is some sort of a La Nina-ish condition. It looks like we're moving more to ENSO neutral, and with those westerly anomalies 2nd of December pretty much taking over, that will be good. I mean, all this is much better than where we've been in terms of support for storm development and precipitation into California. Now to the El Nino, La Nina, or ENSO portion of the discussion, and we're not going to talk about El Nino because it isn't going to happen, right? What we're really talking about is the transition from the weakest of weakest La Ninas to just something that's neutral. We're going to start by looking at subsurface temperatures here. This is data from the TAO buoy array again. These X's are the anchor lines on those buoys from the East Pacific to the West Pacific. The X's are actual sensors on the anchor lines sensing subsurface water temperature down 100, 200 meters. And the colors are, of course, the temperatures. During La Nina, trades are stronger than normal, blowing from east to west. They take the warm water, ball it up here in the West Pacific. During El Nino, trades reverse, or at least weaken. Warm water sloshes to the east and warm temperatures start building up here. Clearly, we're not in that kind of a pattern. The 29-degree isotherm here, about where it was last week, I think somewhere around 172 or 173 east. The 8-degree isotherm here, it was actually over at 176. It slipped back a little bit more. Now, we've been under the influence of the inactive phase of the MJO, and it's just the past week and a half or two that we're transitioning to the active phase. Westerly anomalies are still trying to build. I don't know how far across the Pacific they're really going. Probably not much more than the date line. So this is appropriate. And the 24-degree isotherm, about where it was last week at 120 west. But it is not the absolute temperatures. It is the anomalies, difference from normal for this time of year. Yes, we have warm anomalies in the west. We have cooler anomalies in the east. This was actually, I think, a little bit cooler last week, maybe even down to -3 degrees. Now it's at 2 degrees below normal. And we expect that this, if anything, should be slackening as westerly anomalies start building across the equatorial regions. Here's another chart. Same deal, uses the same information, but it also has satellite data baked into it as well. I'm watching how far to the east these warm anomalies get. Right now we're at about 165 down at the thermocline level, which is 150. So I'll give it 165. At some point, I want to expect to see this start moving off to the east as trade winds diminish. Cooler than normal anomalies. These are actually warming some here, getting cool. Well, not cooler here, but the core of the cool pool moving off to the east, according to this. And this is the satellite data that's showing you the height of the sphere of the ocean. That is, take out the waves, the wind waves, the tides. And is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts, and it displaces water. You'll get a little like a divot on the ocean surface. Likewise, if you have warm water at depth, it expands. It'll displace water up above it, and you'll get a bump. So here we go. This is Chile, Peru, Ecuador here, the Galapagos, that little squiggle there. This is the equator. This is the date line. There is New Guinea right there. Negative anomalies, sea heights, 10 centimeters, 15 centimeters below normal, but it's only 5 degrees north and south of the equator that really matter. And what we see is a generalized 5 centimeter below normal pattern with just right here, 10 centimeters. This is actually better than it was last week. These two little pockets are developing here and another one up here, suggesting some sort of easterly anomalies here. This suggests some sort of westerly anomalies here. Dividing line maybe on the date line sort of thing, but it's not getting any worse here. If anything, I'd say sea heights are rising here. Upper ocean heat anomalies, I mean, really nothing's changed here from last week. East Pacific here, West Pacific here. Here's your warm anomalies here in the west. Your cooler anomalies in the east. The good news is, see these fingers of cooler temperatures? Yes, the milder, warmer temperatures build in coverage a little bit, but there's no core there. And we know for a fact that there's westerly anomalies building here. And I expect to see this edge of the cool anomalies start moving off to the east over time. See it like they do there and there. I expect this is going to start backtracking. And as we get about a month from now, a lot of this might even be completely gone. Sea surface temperature anomalies, South America, Central America, New Guinea, the equator right there, date line out here. This is about like what it was last week. Maybe there's been a little bit of warming of the temperatures out in here, but in general, this sort of weak La Nina-ish pattern indicated 5 degrees north and south of the equator. No real change from last week yet. Sea surface temperature trend for the past 7 days, actually good improvement here. Cooler temperatures is cooling over the past 7 days, just right here from the Galapagos out to like 110. I think it was out at 125 pretty much all week and maybe out at 140 or 160 a couple weeks ago. So this suggests that easterly anomalies in this region are decreasing, allowing eliminating or reducing upwelling, allowing surface temperatures to warm some. Not warm yet, but getting warmer a little bit. Of course, the alternate sea surface temperature anomaly chart shows a stronger La Nina signal than the other. This is probably overstates it. The previous couple of charts understated it, somewhere in between. But still, you can see cooler anomalies, warmer anomalies over here. Here's where your west anomalies are. Here where your eastern anomalies are. Here's the dividing line between the two. As the westerly anomaly pattern builds to the east, we'd expect to see some warming out here and the intensity of this cooling starting to mitigate. The official sea surface trend for the Nino 3.4 region right here, it does it once a week. Latest data from November 5th has anomalies down 0.7 of a degree. So half a degree below normal is the beginning of a weak La Nina. We are officially, well, what do we got? Maybe a couple of scattered readings, but really a month into the weakest of weak La Ninas, and now all the underpinnings of that La Nina appear to be fading out. Here is the sea surface temperature anomaly trend for the Nino 1.2 region. This is the area right there by the Galapagos in Ecuador. Over time, neutral at 0.0. Today's value, minus 1.192. Now, this is not corrected, right? Or modified to try to wipe out the global warming signal. It says temperatures down 1 degree and 192 thousandths of a degree. Neutral is right at half a degree to minus half a degree to above half a degree. But this is not the official El Nino monitoring region. What this is suggesting is that we've been in some sort of prolonged easterly wind anomaly pattern since probably sometime in September. And as of right now, that's still going on. But that said, I believe that this is going to be short-lived. Give it about another week or two, and you're going to start seeing these numbers going up. The official Nino 3.4 index has temperatures at minus 1.192 degrees. Again, neutral is minus half to plus half. Weak El Nino is minus 5 to minus, or minus 0.5 to minus 1 degree. So it's just now that we've moved from a weak to a modest or medium La Nina status. But again, this is uncorrected. And then here's a grab bag of just a couple of charts where this is 850 millibar zonal wind anomalies over the past 5 days. So 0 is the equator, date line's right here. I'm really looking at this area right here, because this is where the far west Pacific starts at 125 east. So it's this area right here that we would want to see the development of westerly anomalies, or at least the mitigation of easterly anomalies. So the 10th of November, you see the blues easterly anomalies getting smaller on the 11th, the 12th. By the time we're into the 13th, it's basically neutral. And then on the 14th, and that's still several days ago, sort of this mix of mainly west anomalies, but weak. But you see, looking over the entire, let's go back here, the entire equator, you see a general, I'd say back here, it was more easterly anomalies. And when you get down here, just 5 days later, more westerly anomalies. Some more data now. And these are not projections. This is real data. Outgoing long wave radiation, cloud cover, the blues, more cloud cover than normal. This would be the active phase of the MJO, and or in this case, more clouds. And so you see there's the entrance to the West Pacific. The blues starting to are taking over the West Pacific. There's the date line. The high pressure, the high pressure bias out here. But it is the anomalies, difference from normal. You see the blues building and pretty much neutral out the rest of the way across the Pacific. Again, indicating at least that we think the change is happening. This one not quite as encouraging. So this is outgoing long wave radiation anomalies. Okay, the date line right here at 180 west. This was last winter. There was our La Nina pattern. This is this year's La Nina pattern. Much weaker than what we saw last year. And then here is where the active phase of the MJO, the westerly anomalies, were last year. And here's the way they are trying to build in this year. Notice last year it didn't really get started solid until January, February. It was a late blooming pattern. But again, this is where if the jet stream is moving over this area from west to east, it'll be picking up momentum. And notice this, no high pressure anomaly or anything going on here supposedly. So a much weaker, it's not that we're getting into a strong westerly El Nino-ish like pattern. It's more like we're just not going to be under the influence of La Nina anymore. So what does the atmosphere think is going on? Well, look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, in the Indian Ocean roughly, and Tahiti in the Pacific. When lower pressure builds over Tahiti, the index goes negative. So today it's plus 8.2. Okay, we want to see it go negative. We saw a couple of days of it there, but look where we were. We were in the 20s, 26 back in the early part of November, and pretty much the entire month of October, the entire month-long period from mid-October up until just about 5 days ago suggested strong high pressure and control over Tahiti. Now that we're starting to see at least some holes or some softening in that pattern. This is due to the inactive phase of the MJO that's been over the West Pacific. It is just now starting to fade and the active phase is setting up. The 30-day average, today's value 14.5. That's, clearly indicative of the inactive phase of the MJO. Where were we a month ago? Yeah, 4.2. So this was the building inactive phase over the Equatorial Pacific. The 90-day average, 7.64. Where were we a month ago? 3.59. Same deal. All this about the inactive phase building over the Kelvin wave generation area. That said, we know as of the past couple of days, westerly, or past week even, the change is happening. West anomalies are setting up, and we think they're here to stay. It's not just purely MJO related. It's a part of a longer trend. Here's the graph of that pattern, the 30-day average running SOI. Upward spikes are like there. These are the inactive phase of the MJO, and you see that here. The big drops are the active phase of the MJO, lower pressure building over the Pacific. Last week I saw this spike and I said that's as high as we're going. Well, it seems like we're there, but we haven't started dropping off the chart yet. The reason being the low pressure westerly anomalies have to make it to Tahiti, and Tahiti's at 140 west. That's a good long ways across the Pacific. So by the time this guy's definitely a lagging indicator. By the time he starts dropping, then one can assume that further off to the west, things are even much more in a low pressure state. And that's what we're waiting to see. And yet even better news. Last week, this is the forecast for the Nino 3.4 sea surface temperature anomalies from the CFS model. For months now, they've been predicting in November, which was right here, this dip that went down to almost -1 degrees. Well, we got confirmed data. It's only 0.7 degrees. You just saw that. So, and this suggests we're going to hang here for about a month as that active phase and that westerly wind anomaly pattern starts building its way across the Pacific. Then after that, we're off to the races. We're effectively technically neutral by Christmas time and heading upward from there. Neutral again, half degree below to half degree above. That's the raw data. The PDF corrected data, pretty much the exact same pattern. So this is as bad as it's going to get, supposedly, for this La Nina. And then within a month, we're off to the races. So for right now, a series of gales forecast. I wouldn't even call them gales, like sort of diffuse storm pattern for the North Pacific. Though as we get mid to later week, a big area of 20 to 28 foot seas is forecast filling most of the East Pacific. So swell should result from that. None of it like an organized long period swell, but just sort of steady, rideable surf sort of thing. And even better news, we're getting rain into California. We're getting real rain into Southern California, and that's that's a godsend. So thank your lucky stars for that. I mean, the realities you saw, they're these fluky little backdoor troughs that are pushing down the coast. So we'll get, a bit more of it into maybe Wednesday, Thursday, Friday. Southern California maybe down to Saturday. But then after that, I think what's going to happen is effectively the inactive phase of the MJO, or sort of the high-pressure clearing pattern, will build over California, while in the West Pacific, the low-pressure storm pattern will start building as the active phase and this change that we've been talking about starts setting up more over the West Pacific. And I think longer term, that will set us up for yet more weather and more storms and surf as we get into winter proper. I mean, we're still just kind of into fall. Winter doesn't start till December 21st or 22nd. So we got a long ways to go. Right now, the pattern seems to be unfolding pretty much like what the models were suggesting 3 or 4 months ago. Maybe a little bit delayed, but still along the same track. Again, we're not talking El Nino. We're just talking a return to a neutral kind of pattern where the high pressure bias that has just been locking down the Pacific for years now might finally start to break up a bit. We'll know more when we go. I think might be another week or two before we get an update on the PDO, the November data. Yeah, we got to get into December. But as of right now, PDO steady at minus like 2.3 or something like that, which is not super bad, but isn't super good either. We want to see it get pushing up more towards zero. I think that's more of a long-term aspiration as we get into February or March sort of thing. All right, that's our forecast for this week. Oh, yeah, and there is some snow in the Sierra, so we're getting there too. That's our forecast for this week. I hope you enjoyed it. If you did, give us a thumbs up. If you haven't subscribed, again, please subscribe. I see the numbers slowly ticking up. Hit the Stormsurf icon down in the lower right-hand corner of your screen. Comment, questions, always welcome. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. That is it for this week. We will do it again next week, same time, same channel. Thanks so much for watching.